Circular Motion 3. Introduction. You have already examined centripetal acceleration, but there is no acceleration without a corresponding force. You are now going to learn about centripetal force. Centripetal force explains how to turn an aircraft, why some motor racing circuits are banked, and how you get round the loop of a roller coaster. In this lesson, you will learn the equation for centripetal force, use it in a range of examples. You need the force with you because if it goes, so do you. But which way? Click play button to start the athlete turning. When the hammer thrower stops, select the correct arrow to show the direction the hammer will travel in. If you have got it right, the animation will continue to show what happens. Click Next to move to the next scene. Click Play button to start the car moving, and then select the correct arrow to show the direction the car will slide in. Move on to the final scene by clicking the Next button and repeat. The force which keeps objects on a circular path is called the centripetal force. In which direction does this force act? Answer: towards the center of the circle. You are now going to start working out the equation for centripetal force. To give you plenty of time, you will be following a snail's progress. Select the correct quantities from the drop-down menus to complete the equation. When the equation is correct, you will be able to select some values for the two quantities which might be appropriate for the snail. Type your answer to the calculation in the box and click Correct button to check your answer. Why does this equation seem to have nothing to do with the snail's motion? Answer: the snail does not seem to be accelerating. Why is the snail accelerating? Answer: because it is moving in a circle. What sort of acceleration is it? Answer: centripetal acceleration. Select the correct quantities from the drop-down menus to complete the equation. This equation is really the same as the previous one. Why? Answer: it is still F equals ma, but the a is replaced by the equation for centripetal acceleration. Select some values for the three quantities. Type your result and click Correct button to check your answer. The equation above is the equation for centripetal force in terms of velocity. What would the equation be in terms of angular velocity? Answer: F equals m omega squared r. Summary: a force is necessary to provide the centripetal acceleration required for an object to move in a circle. A failure of the force will allow the object to move off at a tangent to the circle. The force is directed towards the center of the circle. The force is known as the centripetal force. The equation for centripetal force in terms of velocity is F equals mv squared over r. The equation for centripetal force in terms of angular velocity is F equals m omega squared r. Select the correct force from the first drop-down menu to supply the centripetal force in this case. Next, select a value for speed. Then select the correct value for centripetal force. Click Correct button to check if you have got the right answer and to see what happens to the car. What factors determine whether the car will make it round the corner or not? Answer: the car will make it as long as the centripetal force required is not greater than the frictional force. Here, you have the back view of a car going round an oval track, with flat straights and banked curves. Look at the forces acting on the car as it banks round the curves. What is R? Answer: the normal reaction force. What provides the centripetal force when the car is banking? Answer: the horizontal component of R, r sine theta. What is the advantage to the car driver of the banking? Answer: it allows a higher speed than would be the case for friction alone. This time you have a plane, but it is very similar to the car in the last example. Select the correct force from the drop-down menu. Calculate the centripetal force needed and select your answer from the menu. Calculate the angle of banking by following these steps. What is mv squared over r equal to? Answer: L sine theta. What is mg equal to? Answer: L cos theta. Divide mv squared over r by mg. What do you get? Answer: v squared over gr. Divide L sine theta by L cos theta. What do you get? Answer: tan theta. The results of the two divisions are equal. So what equation do you get linking theta, v, g, and r? Answer: tan theta equals v squared over gr. Calculate the angle of banking. Use G equals 9.81 Newton per kilogram for this and any other calculations you do. Click Correct button to check your answers. The diagram shows a conical pendulum. To see the forces acting on the pendulum, click Show Forces button. You can click Show Forces to get it moving again. Select the force which supplies the centripetal force from the first drop-down menu. Calculate the size of the centripetal force needed and select your answer from the menu. The angle can again be found from tan theta equals v squared over gr. Use this to calculate the tension in the string and select your answer. Click Correct button to check your answers. How would you calculate the period of rotation, t, from the quantities above? Think about time to go around the circumference. Answer: t equals 2 pi r over v. Remember, angular velocity omega equals v over r. What would t be in terms of omega? Answer: t equals 2 pi over omega. Summary. Finally, you are going to look at the roller coaster. This is a case of vertical circular motion. Think about the weight and the centripetal force. How is the situation at the top of the loop different to that at the bottom? Answer: at the top, the weight will be providing some of the centripetal force needed. At the bottom, it will need to be balanced in addition to the centripetal force. Select the correct force which supplies the centripetal force from the first drop-down menu. Now select the centripetal force needed from the second menu. What is the equation for maximum reaction force in word? Answer: maximum reaction force equals centripetal force plus weight. What is the equation for minimum reaction force in word? Answer: minimum reaction force equals centripetal force minus weight. Select the correct answers for the final two boxes and click Correct button to check your answers. Summary. Centripetal force can be provided by a range of different forces. For situations involving banking, The angle of banking can be found from tan theta equals v squared over gr. This equation also applies to the angle from vertical of a conical pendulum. The period of rotation can be calculated from t equals 2 pi r over v or 2 pi over omega.